Dear students, good evening. So we discussed the inverse jet transforms in the last class. Okay, so now we are going to discuss a few problems based on these inverse jet transforms. Okay, so actually this is the applications oriented problems. These are all very important one. Okay. So, do you know about Fibonacci series, the general form of the Fibonacci series? Actually, the general form of the Fibonacci series, for example, one. Okay, so here one. Yes. So the first uh, term is one, and the next term is also one, and the next term will be the sum of the first two terms. So therefore, three. The next, sorry, two. So the next term will be sum of this previous two terms. So three, and the next term will be sum of these previous two terms. So two plus three means five. Okay, so the next term will be eight, and the next term will be 13, and so on. Okay, so this type of sequence is called Fibonacci series or sequence. Actually, this is called a sequence only. Okay, so Fibonacci series. Okay, now as I told earlier, for the given sequence, you have to write the general form. Okay, then you have to find the Z transform, and or if you need, you can find inverse Z transform also. Okay, so this is our basic idea. Okay, so this is Fibonacci series. The corresponding difference equation for this Fibonacci series is this one. Okay, so y n plus 2. Okay, so the yn plus 2 term, this is 2 term will be equal to sum of this previous two terms. Okay, so therefore yn plus 1 plus yn. Okay, so this is for example, if it is yn plus 2, then this will be sum of this previous term. So this is yn plus 1 and this one is yn. Okay, if you add these two, you can get this uh, term. Okay, so this is our common difference equation for this Fibonacci series. Okay, and the first two terms are initial condition. Okay, so here y0 and y1 both are equal to 1. Okay, so this is general form of this difference equation, and this is our initial condition. Okay, so this is our difference equation with two initial conditions. Okay, now we are going to find the solution for this difference equation. Okay, so as I told earlier in the last class, this solution, that means we can use the transforms to find the solution of any type of difference equation, and especially linear difference equations. Okay, so here this is linear. I hope you know the definition for linear differential equation. Okay, so this is also linear because the power of or each uh, degree of each terms are 1. So therefore, this is linear difference equation. Okay. So now we can find the solution of this linear difference equation by using Z transform. Okay. So here the procedure is first you apply the transform on both sides. Then after simplification of all these expressions, take inverse the transform, then you can get the solution of this type of problem. So this is the idea. So what I want to say here, first apply the Z transform for this equation, then take the inverse Z transform for that resultant expression. You can get the solution. Okay. So first look at this. Okay. So already we know that Z transform of u n plus 1. Okay, so this will be equal to Z times, okay, Z transform of un, okay, minus, this is left shifting property. So therefore this is equal to u naught. Okay. Similarly, Z transform of un plus 2. Okay, this is equal to z square, okay, into z transform of un minus u naught minus u1 divided by z. Okay, so these are all the formula. Okay. So now you use this formula to simplify this expression. So here in the place of un we have yn, that's it. Okay, so therefore you take this is 1. Okay, now I am going to apply the transform. Apply the transform, the transform on both sides, both the sides of the equation 1. Okay, so therefore this expression becomes the transform of yn plus 2 equal to the transform of yn plus 1 plus the transform of yn. Okay, so here the transforms can be satisfied that linear property. So therefore I can apply that linear property for the right side. Okay, so this is the y. Okay. So now use this formula. Okay, so here this becomes z square. This is z transform. If you use the small z, that will be result. So small z square into the transform of un or yn. So here yn. Okay, minus y naught minus y1 divided by z. Okay, this is equal to y of z of yn plus 1. So therefore this becomes z times, okay, the transform of yn, okay, minus y naught, okay, and plus the transform of this yn. Okay, so here there is no formula for this one, so you just write with this. Okay, now if you simplify this, but here it is given that y0 and y1 both are equal to 1. So therefore this becomes z square into, okay, so z square into z transform of yn. Okay, and this is 1. So therefore this will be equal to z square. This is also 1. So if you multiply this z square with this, you can get minus that. So this is equal to, and this is 1. So therefore z of the transform of yn, okay, minus that, okay, plus the transform of this yn. Okay, so actually here our aim is to find this yn only. So in difference equation, this is the dependent variable. So in all the equations, any type of difference or differential equation, you have to find the dependent variable expressions. Okay, so in terms of the independent variable. So here the dependent variable is y and independent variable is n only. Okay, so already I told that n is the variable here. Okay, so now you bring all the transform of y on one side. So therefore this becomes z square of z transform of yn. Okay, the minus that z transform of is z, and this one is capital Z. Okay, yn. Next minus z transform of yn. Okay, and this minus z will get cancelled. If you bring this minus z square to right side, this will be plus z square. Okay. Okay. So now our aim is to find the yn only. So you take this z of yn commonly outside. Okay, if you take this z of yn commonly outside, then this expression becomes z square minus z minus 1. Okay, and the right hand side we have this z square. Okay, so now you find this z transform of yn. Okay, so that becomes z square divided by z square minus z minus 1. Okay, now you take inverse z transform for this yn, then you can get the solution. Okay, so far we have discussed only the partial fraction method to find the inverse z transform. So therefore you try to use partial fraction method to find this inverse z transform. Okay, so you just look at that. So as I told you earlier, the resultant expression of the z transform will contains z in the numerator. So therefore, we just keep one z in the numerator and take the partial fraction for the rest of the function. Okay, so this is numerator z, and the remaining term is z by z square minus z minus 1. Okay, so that's it. Okay. So now yn is the solution. So this will be equal to inverse z transform of this z into z by z square minus z minus 1. Okay, so you have to take the partial fraction for this function. Okay, so now look at this partial fraction. First I am going to find the partial fraction. Okay, for this function z by z square minus 1 z square minus z minus 1. Okay, okay, so here okay, so partial fraction for z divided by z square minus z minus 1. Okay, so first you factorize this expression. Okay, if you factorize that, then this will be equal to z square minus z minus 1 equal to 0. So z will be equal to plus 1 plus or minus root of b square minus 4ac. So minus into minus plus, so 4 divided by 2a, so 2. Okay, so this z will be equal to 1 plus or minus root 5 divided by 2. Okay, so one root of this expression is 1 plus root 5 divided by 2. Another root of this quadratic equation is 1 minus root 5 divided by 2. Okay, now take for our calculation part. Okay, you just take this as a and this as b. So therefore right now you just assume this expression is a and this expression is b. So therefore the factor of this equation is z square minus z minus 1 will be equal to z minus a into z plus sorry z minus b. Okay, this is z, this is also z. Okay, but at the end we can replace this a by this expression and b by this expression. Okay, so right now you just take these factors. Okay, so this z divided by z square minus z minus 1 can be written as z divided by z minus a into z minus b. Okay, this is our factorized form. Okay, now take the partial fraction. This is simple factor, so therefore this can be written as a by z minus a, okay, plus b by z minus b. Okay, So now if you take the cross multiplication, then this becomes z is equal to a times z minus b plus b times z minus a. Okay, and if z is equal to a, then this capital A becomes a by small a divided by a minus b. Okay, if z is equal to a, okay, then this becomes 0. Okay, so that a will be this one. Okay, similarly, if z is equal to b, then this term becomes 0 now, and here b is equal to capital B times b minus a, but I want to keep this denominator same, so therefore you take one minus commonly outside, so therefore this capital B will be equal to minus b divided by a minus b. Okay, so that's it. I have taken one minus commonly outside. Okay, so now this is the partial fraction for this one. Okay, so z divided by z square minus z minus 1 can be written as a by a minus b into um, 1 by z minus a. Okay, minus b is b by a minus b into 1 by z minus b. Okay, so this is our partial fraction, but where a and b are this value. Okay, you don't forget that values. Okay, now you go to that inverse the transform. Yn is equal to z inverse of, already we have one z here. Okay, so z time this factor, so therefore this factor is equal to a by a minus b into 1 by z minus a minus b by a minus b 1 by z minus b. Okay, so these are all factors. Okay, this z is common for this both terms. So now if you multiply this with this a by a minus b is constant term, so therefore we can take it out a by a minus b, and z inverse of z by z minus a. Okay, similarly here minus b by a minus b, so this is constant, and if you multiply this z here, you can get z inverse of z by z minus b. Okay, now this will be equal to a by a minus b, and z inverse of z by z minus a will be equal to a power n. Okay, similarly minus b by a minus b, the z inverse of z by z minus b is b power n. Okay, and here you just to find a minus b value. Okay, already you know that a is equal to 1 plus root 5 divided by 2, and b is 1 minus root 5 divided by 2, so therefore a minus b will be equal to this 1 by 2 1 by 2 cancel, so 2 root 5, so root 5 will come. Okay, so you just check this calculation, and here a is 1 plus root 5, so 1 plus root 5 divided by 2 into root 5, okay, into a power n minus b is 1 minus root 5 divided by 2 into root 5 into b power n, and b is what? B is 1 minus root 5, so you write that also, root 5 divided by 2 whole power n, and here also 1 plus root 5 divided by 2 whole power n. Okay, so this is the solution of this equation. Okay, so 1 plus root 5 divided by 2 root 5 into 1 plus root 5 divided by 2 whole power n minus 1 minus root 5 divided by 2 root 5 into 1 minus root 5 divided by 2 whole power n is the solution of this Fibonacci series difference equation. Okay, so this is a important one. Okay, next problem. Second one, look at this simple problem. Y n plus 1 minus 3 yn equal to 4 and y naught is equal to 1. Okay, so now we have to solve this equation. So these are all called difference equation. Okay, so first you take, as I told you earlier, first you take z transform on both sides. So z transform of y n plus 1, okay, minus 3 times z transform of yn is equal to 4 is constant, so z transform of 1. Okay, so here if you apply that formula, this will be z into z transform of yn minus y naught. Okay, minus 3 times here this will be z transform of yn only. So 4 into z transform of 1 is 1 sorry z by z minus 1, isn't it? Okay, already you know this one. Okay, so now if you multiply this and y naught of y naught is 1 only, so this is 1 only. So therefore if you multiply this, you can get z into z transform of yn and minus small z minus 3 times z transform of yn. 3 times z transform of, sorry, this is capital Z transform of yn. Okay, so this is 4 into z by z minus 1. Okay, now you can take this z transform of yn commonly outside from these two terms. Okay, if you take that, then z transform of yn is into z minus 3 will come. Okay, and this minus z, if you bring this minus z to right side, you can get 4z divided by z minus 1 plus z. Okay, so z minus 1 plus z. Okay, so now you simplify this. Okay, if you simplify this, you can get z transform of yn is equal to 4ez. If you multiply this with this, you can get plus z square minus z whole divided by z minus 1 into z minus 3. Okay, so now this z transform of yn becomes z square plus 3z whole divided by z minus 1 into z minus 3. Okay, so as I told earlier, we can keep one z the numerator. Okay, so if we keep that z in the numerator, then yn is equal to inverse z transform of z times z plus 3 whole divided by z minus 1 into z minus 3. Okay, now we have to take partial fraction only for this part. Okay, so just look at that partial fraction. So z plus 3 divided by z minus 1 into z minus 3 equal to a by z minus 1 plus b by z minus 3. Okay, so z plus 3 is equal to a into z minus 3 plus b into z minus 1. Okay. Now take z is equal to 3. Okay. If z is equal to 3, then this becomes, if z is equal to 3, then this becomes 6 equal to um, 2b. Okay. So this implies b is equal to 3. Okay. Similarly, if z is equal to 1, then this 4 is equal to minus 2a. So a equal to minus 2. Okay. So therefore, the partial fraction of this part is yn is equal to z inverse z transform of z into, instead of this part, we can write this one. So first to write the positive term. So 3 by z minus 3. So 3 by z minus 3. Next negative term is this one. So here a is minus 2 in by z minus 1. Okay. Then you multiply these things with this z. Okay. So if you multiply this, then yn is equal to inverse z transform of 3 times z by z minus 3 minus 2 z by z minus 1. Okay. Now you can take this inverse z transform 3 times 3 power n, and here minus 2 and 1 power n. Okay. So therefore, this can be written as 3 power n plus 1, and this can be written as 2, because 1 power anything is 1 1. Okay. So this is the solution of this given differential equation. Okay. So far we have discussed only simple differential equations only, but in future we will discuss some different type of differential equations and their solutions. Okay. So I stop this session here. Thank you. Thank you for your attention.